We've just looked at factorizing monic quadratic expressions by coming up with two numbers that when multiplied give you the constant term, the c, but when you add them together you get the middle term, or plus b. Now, non-monic quadratic expressions, okay, a little bit different. Still quadratic because the highest power of the expression is 2, of the variable in question is 2. And it's non-monic because the coefficient of x squared is something other than 1. In other words, it's not exactly one of these x squareds. It could be 2, 3, 5, could be 0.1, could be anything, right? It's not 1. But it obviously can't be 0 either. And if a is equal to 0, then guess what? That disappears, and you're left with bx plus c, which is linear. So we don't care about that. So we'll stick to the non-monic case here, okay, where a is some value other than 0 or 1. Now, there's two methods that we can use to factorize these non-monic quadratics. And the first one is the cross method. Okay, so we'll draw a big letter X, and we'll have a look at that, and we'll see how that works. And it's a diagrammatical method. There's another method which involves grouping in pairs. Now, there's other methods as well, but these are the two that I'm going to focus on in this video. So, and I'm going to use a combination of these methods so you can see both of them in action. However, it is also possible to use the quadratic formula. Now, if you already know the formula, that's great. If you don't worry. Okay, but the quadratic formula is actually very, very powerful and can actually be used in the process of factorization as well. And that's the formula x equals negative b plus or minus square root of b squared minus 4ac on 2a. Okay, I'm going to do one example though, which will use this formula to show you how it could work. Okay, but you don't have to use that obviously, okay, when factorizing these kind of expressions. Right, let's have a look at some examples. All right, so first one. So we've got 2x squared plus 14x plus 24. The first thing you should try and do though is common factorization first. Can you take out a common factor or take out the highest common factor? If possible, if that is in fact possible, then you may be able to reduce a non-monic quadratic into a monic quadratic, and that definitely simplifies things. So let's see. In fact, all the coefficients there are even. Okay, so coefficient of x squared is 2, coefficient of x is 14, and the constant term is 24. So why don't we take out the highest common factor, which is 2, and then we're left with x squared plus 7x plus 12. Now, x squared plus 7x plus 12, that is monic, which means that we just need to find two terms that when you multiply them together, you get positive 12, and when you add them together, you get positive 7, and that's obviously 4 and 3. So we can integrate those as part of our solution. So that's going to be x plus 3, x plus 4. Okay. So I can tell you from now, all the other examples, there's no highest common factor. In other words, the highest common factor is 1. It's a non-unity, or it's the HCF that's not 1. All the rest here have HCFs of 1. Okay, so we can't use this method. But nevertheless, especially in an assessment or in any particular questions you look at, the first thing you try and look at, highest common factor. Let's have a look at part B. 2x squared minus 5x minus 12. Now I'm going to use the cross method here. The cross method, I like the cross method because it's diagrammatic, right? It's a way of planning the solution out. And for a lot of viewers, that might be the better option for you to use. It might be a little bit more laborious, a bit more tedious, but because it's a diagram, and in fact it's a fairly well organized diagram, it helps you to plan your solution. Okay, so you draw it for a large x, and then you put a little sort of a small x there, and you put a plus sign there. Okay, so and then just put a little sort of an underline there. And then now what you're going to do is you're just going to place some terms under these lines here, these horizontal lines that I've just written. So under the first one, you write 2x squared. Under the second one, you write negative 12. You'll see how this is going to work shortly. And under the third one, you write negative 5x. Okay, now this part, you could probably do this in pen. The next part, which may involve some trial and error, you can do in pencil, and then when you've found the correct solution, you can then obviously draw over it or write over it in pen. So the way the cross method works is like this. Okay, you try and find two terms, okay, that when you multiply them together, you get 2x squared. Now 2 being a prime number, there's only one option there. So you have 2x up the top there, x on the bottom. And it doesn't really matter which way you put these. I usually just put the larger one on the top. Now, the next thing is you need to find two terms that when you multiply them together, you get negative 12. And there's a few options there, in fact. And in fact, which one you make negative and positive also matters as well. So let's have a look and see, I don't know, maybe try, being negative 12, one's got to be positive, one's got to be negative. So maybe we make this one positive 4, and maybe this one negative 3. It's a viable solution. I mean, it's a possible solution. Then what we do is you multiply along the large x. So 2x times positive 4 is positive 8x. X multiplied by negative 3 is negative 3x. And the reason why we do this is we sort of acts as a bit of a check. Are the terms that we've chosen, if they were in a binomial and we multiplied them together, would you get a middle term of negative 5x? Well, negative 3x plus 8x, you get positive 5x. So this is wrong. Okay, so negative 3, positive 4 is clearly wrong. We could, in fact, move the negative 3 down the bottom and the positive 4 up the top. So this is why it's important that you inspect this carefully, okay? And, you know, just consider your options. Don't just randomly sort of put numbers there, but think it through that if you multiply it along, you want to try and get terms so that when you add them together, you get negative 5x, okay? So I think if we had a negative 8 here and a positive 3 there, I think we'd be happy. So what we're going to do, this is why it's good to do this in pencil, this part anyway. Let's make that positive 3, okay, and the 4, instead of positive 4, let's make it negative 4, and let's see what happens. So 2x multiplied by negative 4 is negative 8x. X multiplied by positive 3 is positive 3x. Now 3x, I'll just put a positive there, positive 3x plus negative 8x is negative 5x. Okay, so I think we're happy with that. And how would we write our solution? I'm just going to, I need a little bit of extra space here. So in fact, let me just see where I'm going to write the solution. Just bear with me. I'm going to write the solution here. So what you do, okay, if you put brackets around these, okay, what we've just come up with, so 2x plus 3, x minus 4, that would in fact be our solution. I'm just going to write the solution here in fact, so just bear with me. We've got, that's 2x plus 3 multiplied by x minus 4. Okay, we have to be quite creative sometimes. If I run out of space, I just have to find a little bit of real estate to write the solution, but ordinarily would have had a bit of extra space there. So that's your solution. That's using the cross method. Okay, so 2x plus 3, if you multiply it out, do you get 2x squared minus 5x minus 12? You should. 2x times x gives you 2x squared. 2x times negative 4 is negative 8x. 3 times x is positive 3x, so that's negative 5x. And negative 3 times negative 4 is negative 12. I think we're happy there. All right, next one. 4 minus 3x minus x squared. Thankfully, this one's not too bad. It almost looks like a monic quadratic, doesn't it? Well, why don't we factor out negative 1 and we'll see what happens there. So if we factor out negative 1 to make it a monic quadratic, in fact, just before I do that, why don't I write it so that the x squared term is first, and then I'm just going to rearrange the terms first so you can see what I'm about to do. Now, let's factor out negative 1 out of this entire expression. So again, this is the highest common factor. And now the highest common factor is negative 1. Now, I know what I said earlier on in the video that there's no other example that has a HCF other than 1. This one sort of kind of bends that rule a little bit, okay? It's a HCF of 1, but it's actually negative 1. So taking out the negative, okay, we end up with x squared plus 3x minus 4. Okay. So you've kind of you've turned it into a monic quadratic. Technically speaking, this is not monic, as in 4 minus 3x minus x squared. For a quadratic to be truly monic, it's got to be a positive 1x squared, not negative 1x squared. Okay. Right, now we can factorize the monic quadratic that's inside the brackets there. So x squared plus 3x minus 4, I can think of positive 4, negative 1, so it's going to be x plus 4, x minus 1. Okay. Another way that we could factorize this as well, if you wanted to express it in factor form, would be, we could write it as x plus 4, and then 1 minus x, if we couldn't be bothered showing the negative sign out the front there. So multiplying the second bracket by negative 1 just makes the x negative and the 1 positive. This is also possible to express it in this way. But it's also okay to express it in this way as well. Okay, so let's have a look at part D. Okay, so part D, we could use, again, the cross method again. And why don't we do that? Hopefully this time I'll have a little bit more space. So draw the x. Okay, so you should get used to this now. All right, put a little x there, because we've got to remind ourselves that we're multiplying sort of vertically, aren't we? You know, so little dashes there and a plus sign there. Okay, so I kind of feel like I'm on a cooking show here, sort of I'm cooking up some maths. All right, let's see what we do next. What goes under here? Right, so under the first one we put 12x squared. Okay. Under this little dash here, we put the constant term, which is y squared. Okay, and under this this dash here, we put the middle term, which is 7xy, negative 7xy. Okay, now I'm going to change to a virtual pencil, which is a red pen. This time around, I'm going to do things a little bit differently. Two terms that when you multiply them together, you get y squared. Well, that's pretty easy. So it's just going to be y and y, isn't it? Uh-huh. Why? Because it just is. Right. Sorry, lame joke. Right. What about 12x squared? So two things that when you multiply them together, you get 12x squared. So think of 6 and 2, 4 and 3, 12 and 1. I'm just trying to think here what cards are good. Maybe 4 and 3. The reason why I choose 4 and 3 is because I've got a negative 7 here. Okay, and it's a negative 7xy. Oh, okay. I think what I've got to do, that's a negative. Yet I've got positives here. Oh, I think I have to make these negative. Well, let's have a look. Let's make this say 4x and this one 3x. Now 3x times y gives me positive 3xy. 4x times y gives me positive 4xy, but I need a negative 7xy. So I have to put negative signs here. Does that still work? Yeah, of course it does. Negative y times negative y gives me positive y squared. After all, the product of two negatives gives you a positive. So I think we're happy with that. Let's just confirm this, that in fact we're on the right track with it. 4x multiplied by negative y, so now multiplying along that sort of the large x. 4x multiplied by negative y is negative 4xy. 3x multiplied by negative y is negative 3xy. Negative 3xy plus negative 4xy is negative 7xy. I think we're happy. All right. So the way we would then write our solution, okay, is just what I've put in brackets there. Just write it out. So that's going to be 4x minus y and 3x minus y. Of course, you can verify your answer. What would you do? You should expand, okay, that expression that you've just come up with, the factorized expression, and check to see that make sure that it actually corresponds to the original expression that we started off with. All right, let's have a look at a couple more examples now. So that's this one here. Okay, so if you like, you can have a go at this. You can pause the video and have a go at these two for yourself. All right, this one, okay, I'm going to use the grouping in pairs method. So I think, as I've said earlier on, I do want to show you just a different method here. And you can choose which method, obviously, that works best for you. And there's no better method than another. It just depends what works, and everyone's different, and you just choose whatever comes naturally to you. Right, 12x squared plus 7x minus 12. What we want to do is we multiply the coefficient of the x squared and the constant term together. So what you want to do is you want to find, right, two numbers. Right, right, whose product is equal to 12 times negative 12, which is negative 144, and whose sum is positive 7. Okay, so sort of they're the two numbers that we're dealing with here. So you'd need to kind of experiment here a little bit with the factors of 144, and let's just see what we could come up with there. And you want the sum to be 7. Now we know 12 times 12 gives you 144. Have a think about what other factors go into 144. We can try 16, positive 16 and negative 9, right? So the two numbers are positive 16 and negative 9. Okay, so these aren't the factors, but we're going to use that to find the factors. So what we need to do next is we need to split this middle term up so that it sort of break it up into two terms. So we end up with a quadrinomial, an expression with 4 terms. So let's break it up. So we've got 12x squared. The 7x really is plus 16x, right, minus 9x minus 12. Okay, can you see where this is going now? So what we've done is that we've converted this trinomial, remember, so trinomial, 3-term quadratic, into a 4-term kind of quadratic, if there's such a thing, right? I mean, all we've done is that we've just broken the 7x up into 16x minus 9x. Right, now we can factorize by grouping in pairs. We've done that one already. So in fact, we could just keep the first grouping the same. So 12x squared plus 16x, we can take out 4x, can't we? So that's the same as 4x, and in brackets we'll have 3x plus 4. Okay, and for the second pair of numbers there, we can take out negative 3, and we end up with 3x plus 4. I like this one. Comes out nicely, doesn't it? What do you think? 3x plus 4, 3x plus 4, that's our common factor. Right, and then what's left, that's outside the brackets, you've got 4x minus 3. Now, does it work? You might think, oh, I don't know, does this make sense? Well, let's see. 3x times 4x, that gives us 12x squared. Positive 4 times negative 3, that gives you your negative 12, so that's okay. What about the middle term? 3x times negative 3, that's negative 9x. Positive 4 times 4x is positive 16x. And when you add those together, you get 7x. So, happy with that? All right, last one. Now, this one, I'm going to use the quadratic formula for this one because I think it's good to be able to, again, just see another method. You don't have to use this method, okay? It's just one that, I guess, comes from the property that if you can factorize a quadratic, it's a quadratic that is in fact solvable. In other words, later on when we look at quadratic equations, a factorizable quadratic is a solvable quadratic, a quadratic that can be solved, as in with real solutions, that is. A quadratic that can be solved is also factorizable. Okay, you might not get integer factors, but you get something, right? You'll get a real factor of sorts. So we're going to use the quadratic formula here. I'll use a different color pen for this one. Okay, so what we're going to do is I'm going to write this just in the correct order. So 14x squared minus 29x plus 12. Okay, I'll use a different color pen just to make this a little bit easier. So there's our A, there's our B, and there's our C term. Right. Okay, so x. Okay, so what we need to do, we need to find the two numbers first that are of importance to us, and then we'll work out the factors from those two numbers. So x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This method, by the way, this is the non-guesswork method. You'll get it the first time. You will find the factors, known as trial and error. So it's kind of what I guess why I gravitate toward this actually. So, however, with certain questions, this might take longer. So Probably easier if you can factorize it using the other methods first, because they're generally going to be a lot quicker with those sort of questions. Right, the b term is negative 29. Okay, so x is equal to, so negative 29, so it's going to be positive 29, plus or minus b squared minus 4ac, so b is negative 29, minus 4ac, so minus 4 times 12 times 14. Sorry, AC, doesn't really matter which order actually. Actually write it here, so 4 times 14 times 12, you would get the same answer anyway, over 2a, so a is 14, so it's going to be over 28. Right, now what we're going to do is we're going to come up with our two values of x. Okay, so I'll just bring the calculator over, hopefully you can see that okay, and turn it on, yep. Alright, so we've got 29, we'll do minus first, so square root of, minus 29 squared, okay, minus 4, multiplied by 14, multiplied by 12, over 2a, so that's going to be 28, and we get 4 on 7. Alright, and the other one, the other value that we need, okay, you'll get two of them. So hopefully just got to scroll back to, yeah, change that minus into a plus, and we get 3 on 2. Very nice. Okay, so the way we then write these factors, okay, is, right, x minus 4 on 7, x minus 3 on 2. But the problem that we have here is that we can't have fractions. We can express this using whole numbers. So what we're going to do is we're going to write these as whole numbers by multiplying this first bracket. I'm going to multiply that by 7. And I'm going to go to multiply this one by 2. Okay. So what we end up with is, right, 7x minus 4, and this one will be 2x minus 3. Now, let's see if this works. Let's see if this actually makes any sense to us. 7x times 2x gives us 14x squared. Great. Negative 4 times negative 3 gives us positive 12. So far, so good. Now, 7x times negative 3 is negative 21x. So I might just do this one as a bit of a check here. So 7x multiplied by negative 3 is equal to negative 21x. And negative 4 times 2x is negative 8x. Okay, so negative 4 times 2x is equal to negative 8x. Negative 21x minus 8x is negative 29x. It works. Okay. Definitely more complicated, yes. However, no guesswork. Okay, it will work basically every time, at least for the examples that we've seen. The quadratic formula method will work every time. So I would say use it at your own risk. You don't have to use this method, but it's one that definitely will give you an answer that with far less guesswork.